This is JAIRUS and I'm about to build a real-life Power Fist, Part 2. Let's get started because I don't have that much to do. All I've got to do is finish the frame on the impact plate, the hand protection guard, all the hoses, the electronics, and my air supply system. And the foam, and paint. Sounds like a lot, it's really not that bad. Let's get started. I've got all these little plates of steel. I'm going to trim them down and cut them to shape and weld them on, and this will be all my reinforcement for the impact plate thingy. These little plates are not just reinforcement, but they'll also act as the stops for how far back this is supposed to retract so it doesn't blow my cylinder out. Actuator. There we go. I'll put the other reinforcements on, but I just wanted to show you now it can slam back and forward, and it's metal to metal, it's not actuator to actuator. So now it can smack around as hard as it wants and it's not going to hurt anything. Time to put the handguard on. After looking at all the different ways that I could do this, I think I'm going to mount these right here, because having the least amount of space possible between the actuators and the solenoids will make the reaction time faster, because the gas has to travel less distance. And if I mount these on this, then I don't have to weld more plates on here. I can just drill holes and do it. Now the only thing I'm worried about is the impact. This electromagnetically moves a valve system back and forth inside. I'm afraid the impact will make it actuate to the opposite direction. I don't know if that'll happen or not. But hey, why not experiment? I'm getting kind of tired of thinking about it right now, so I'm just going to drill some holes and mount these on and start getting everything set up. And we'll see how it works. These are going here. Where'd you put it? Where's my center punch thing? I know you took it. Must be here. Ouch! Found it. I knew you hid it from me. Blam! Solenoids attached. Do you remember way back in part 1 when I told you how these wouldn't fit that because they were different thread size? Well, I had to order these on Amazon, little adapters that these thread into and then thread into the actuators. Now that I got all the fittings on, I can try the hoses out. And I should mention this is all test fitment just to make sure everything's going to fit and work out. I'm going to have to clearance some of the metal to get these to tighten in the whole way. But everything's going to work so far. This is good. My lines in. These will feed me the CO2. CO2 comes in here, goes through these two lines, into those, pushes it back, pushes it forward. Awesome! Before I go any further, I want to show you my CO2 regulator, because this was a pain in the butt. On the original out port, I had to take the original stem out and put an 1/8 to 1/4 adapter in so I can put my push-to-fit connector in there. Second issue, it's a flow gauge, so the gauge doesn't tell you how much PSI it's running, it tells you how many cubic feet per minute you can get. So I had to take that gauge out and put this one in that now has pressure readings on it. So now it's a pressure regulator instead of flow regulator. The last issue was the stem for the inlet. So we have outlet, inlet, and the stem that came on the inlet was set up for an argon tank, so I had to put this one on for a CO2 tank. But then I wanted to run a paintball tank right here so that I could plug this in easily and put it on a backpack and it's not that big. So I had to get a paintball tank CO2 tank adapter instead of this, which fits a 5-pound or larger CO2 tank. Time to put some wires on. So this whole top is where your connections are for the electromagnet thing that moves the rod back and forth inside your solenoid, or your valve system back and forth inside your solenoid. So it has these two little clamp positions where you connect your wires and then you run them out through this cover that goes over it. See, it's got that hole you can run the wires out through. So I need to put my own wires in and then bind both of the solenoids together and connect it to my battery pack. Runs on 12 volts. Says so right there. Instead of continuing to show you shots of me cutting and drilling stuff over and over and over again, I just decided to make the parts, and now I'm going to show them to you, and I'm going to explain my plan, because I had no idea how I was going to do this, and I came up with something, and I think it might work. We'll find out whenever I go to use it, but now I'm going to show you the parts and explain it to you. And I drew you a picture to help me explain it to you. This is my spring plate for the switch in the front. This is my on button rod. This is my guide rod that the little on button rod goes through, and that'll push the on button, which is this. And then this is the plate that the on button mounts to. So that'll go on there, and then that'll get welded in place. And then this is made out of T6 aluminum, but it's bolted to a little steel plate, so that'll get welded to the side. And then this washer right here will get welded onto the end of the guide rod. That way it doesn't fly out the front. It'll just basically hold it in place. So this is going to push on this piece of the plate here. And if you see, when it pushes on it, the other part moves also. So when you go to hit something, and that rod gets pushed in, it moves this piece also. Whoop, right? And then this will push on that because it's split right there. So this will get pushed and this piece will move and it'll push the on button. And the whole reason for all this is I need this to stick out way in front so that it turns on before you actually get to something to make impact, right? So this will push way back in against that plate and flex this and turn it on, and I did it like this so that there's a lot of play between them. That way it's not, you know, breaking stuff. Anyway, I got a spring and I was going to try that, but this seemed like a better plan, so I went with this idea. This is the view of the picture. Now here's the picture, and you can see how it's going to work out. This is where my spring plate is mounted, and that piece goes over. Oh, there's some weld. That piece goes over and sits underneath where the rod comes back through. And then this piece will be bent a little bit and it'll push on the switchy thing right there. So anyway, this gets pushed back in, that gets pushed, it moves that, it turns it on, and then bam! This comes out and smashes stuff really hard. Hopefully it works, because it took a lot to make all this little stupid stuff. Come on! So my aluminum spring panel piece didn't work. This would bend permanently and then it would keep the switch on. So this idea is gone. So now I decided I'm going to safety wire this spring to the sides diagonally across the impact panel. And then after I do that, I'm going to safety wire it to this, and which is the on button pin that sticks out. So I'll safety wire it on to these two things, and then hopefully this will work, and then I'll just have the little on switch arm come over and go through the spring some, and yeah. Try number 2. Got that attached. Beautiful. Now I just need to tune this little rod coming from the switch. Hear that? Turns on immediately. Oh no. I'm going about this all wrong. If you can see, I'll make you be able to see. How about that? That's way bright. I kept trying to put this little bar on top of the spring. That way, whenever it pushed, it would turn it on, but that's just silly because I can put it on the bottom and then just safety wire it like I did with that, except, you know, the opposite side. And then it'll hold fine. And it got plenty of length and it'll slide back and forth. This is going to be great. Well, that's pretty much what... Yep, that's going to work. That's what I wanted. Alright, switch is finished, woo! I think it's time to paint this thing, which I cannot wait to do, because I think it's going to make it look so much cooler. So now I'm going to tape off the stuff that I don't want painted and give this thing a coat of yellow, since that's the color that it is in the game. Actually, I'm going to use marigold, not specifically yellow, but it's... I'll just show you. This is sunburst yellow, this is marigold. I like this, and I think it's going to look more like the game, so this is the color it's getting. I forgot one thing. I gotta drill the holes for the LED power indicators. Should I do 4 or 8 LEDs? I know there wasn't 8 on my fingers. I'm just thinking out loud. It'll be a little more wiring, but I think it'll look cooler. So I'm just gonna wipe everything down with thinner so that the paint sticks better. And then I'm going to mask off and paint everything that I want to be yellow, yellow. And then I'll take off the stuff that I want to be metal colored, and I'll paint that with clear coat. I don't know if I'm going to use gloss or semi-gloss, satin finish. I don't know. But I'm going to cover it with clear coat to help prevent rust in the future. But I don't really care if this thing gets rusty. I don't plan on it lasting the next 100 years. Any famous last words? Maybe I'll need it in the next 100 years. Who knows? I should also mention that I don't care a whole lot about the paint job on this because it's supposed to look rough, you know? Fallout, end of the world. How many professional painters do you think there's going to be if the world ends? Think that'll be a popular profession? I don't. Remember, the more time you take to mask stuff off, the better it looks when you're done. I got some birds that made a hole, and I can hear them inside of the garage right now. It's chemical warfare time. Gonna get them. I have a feeling that'll keep them from coming back. If it doesn't, more desperate measures. Here goes nothing. Coat number 1. Time for the second coat. Now I'm going to take the tape off of the parts that I want to be metal colored and hit the whole thing with clear coat real quick. For protection, somewhat. A little bit. It's not going to be that protective because I'm using Walmart brand clear coat because it's all I could find. I mean, at my house, not at the store. Obviously I could get Rust-Oleum if I went to the store. Did you ever notice that masking tape doesn't stick when you want it to, and when you want it to come off, it won't let go? Well, that looks pretty cool. Time to put this thing together and do the wiring. What in the Sam Hill? I really should have marked these so that I know which side they go on. See, wrong side. There we go, that's the right side. At least there's only 2, so I can only screw up once, you know? Get the fuck out of here. Time to do wiring. This is pretty simple because we have 1 battery pack, 1 switch. The solenoid is all that's necessary, but I'm putting LEDs on it also. So basically what's going to happen is the negative wire from the battery pack is going to come over to the common connection on the switch. Now common means that this is always connected to one of these two, open and closed circuits. So the normally open means that when the switch is not depressed, there is no current flowing to this. And when it's not depressed, this one is closed. Normally closed means the circuit is closed, which means this one does have current flowing to it. So basically, the ground will be connected from this to the LEDs. Now I'm running 12 volts, so I'm going to have two sets of 4 LEDs that are run in series. So since these are all 3 volts, 3 volts times 4 is 12 volts. So then those all get connected like this, that way their voltages get added. And then this will come back around and it'll go to the positive side. That means whenever you're not punching something, the normally closed circuit will have the LEDs turned on as long as the battery pack is turned on. So it serves as an indicator of whether the on-off switch on this is on or off. So then the only other thing to connect is the solenoid, which will come up here and go back to positive. This is where the positive one goes. So its ground is interrupted by the normally open switch. So this will come down and connect to the negative leads off of the electronic solenoids. That way whenever this gets pushed in, it'll turn on these and they'll activate and the LEDs will turn off, which you won't really notice because this won't be on very often. But anyway, that makes it very easy. And then this will come down and the positives will tie in. So there's your wiring diagram. I don't know how to draw an actual one, but I feel like that's simple enough that you can figure out how to do it. I'm really glad I turned the camera on to do that. I almost forgot to hit record. I'm gonna hot glue these wires into position, mostly because I don't know how else to secure them and make them stay where I want them to stay. Pretty much. Now I especially don't want to take the switch out right there because then I'll have to re-safety wire it and I'll have to bolt it back in, which was a huge pain. So there's so little space, there's no way I could possibly show you me soldering the wires to those connections. So I'm going to turn the camera off and do it without you watching. I did it. So I have these little bulk containers of LEDs that I got online for cheap, and I wired up 4 of the green ones and I didn't know what their voltage was, and I looked online and it said it was 3 volts, which would be right to wire 4 in series because that makes 12 volts. But I tested them before I mounted them in this, and 12 volts was too much for that and it burned them up. So all the work I did with those I have to redo with these clear ones because I just used my little breadboard here to wire them, to test them, to make sure I didn't like put it together and then burn them up and have to do it all over again like I am now. And these work, so I'm using clear ones because these apparently are actually 3 volts. Anyway, now I'm going to put clear ones in. Negative side's wired. I'll connect the positive wires here and then link it in with the positive wire from the solenoids, and then I can mount these in place. And I'm just going to use hot glue to stick them down. And I'll show you what I'm done, because again, this area is so small, you wouldn't be able to see anything while I'm working at it. Sorry. Alright, I'm done. Got everything hot glued down in place. I got tired of burning my fingers on the hot glue, so I used some notebook paper to push the hot glue in right here. That way it gave me a little bit of insulation, didn't burn quite so bad. The skin's starting to peel off my fingers with the hot glue, so I had to have something to help me out a little bit. Anyway, that's done. And I'll show you the lights, and then I put some tubes on and loom and the foam, and I'm going to zip tie some stuff in place, and then it's ready to rock and roll. Check that out. Alright, this is how you hook your lines up. These, I have this side hooked up. This side's done. And I looped it around so that it's not kinked too tight. So I'll do the same thing with this one. So this will go in here and just push to connect, so you push it in, it's tight. and then it'll loop under this and then through here so that it stays together with the other one. Now the reason I don't have a T-fitting right there is because the more line I have to each one, the more air I have, or CO2 that I have expanded at 120 psi without having a reservoir tank, you know, with like, that way there's no restriction from the regulator. You get what I'm saying? Anyway, yeah, so those come out there and then they meet up with the wires and then that'll all go in loom. And then this is the one that is normally open, or well, opposite than an electrical switch. This one's normally open, so this one will always have pressure and it'll hold the plate back, so that gets put like that. And then in order to make this one work, you just make it a little loop right there to link in, that way it isn't kinked too bad. And bam, your tubes are done. Forget to show you the foam. I just cut recesses to make sure that it fits in where the stuff is at, like the LEDs and these side rails, because they cut in some. And this is just packing foam that I found, you know, it's closed cell, I think. Yeah, it's closed cell, it popped. Wherever you can find that works, you know, it's for comfort. It's not like it matters that much. Plus it's a POWERFIST, you know, as long as it hurts somebody, including you, did its job. That's what it's supposed to do. So anyway, you just put the foam in, then you got your little foam comfort ring. So now I'm just going to stick the rest of the foam pads on, and I'm going to use this to cover up the air lines and the electrical that goes to the backpack that I'm about to build. Alright, it's all done. You can see I put the foam on here, and then I put tennis racket stuff. Tennis racket grip handle thing wrapped there. And there's duct tape underneath it. I wanted it to be fatter, so I wrapped it with duct tape a bunch, and then I put the tennis racket stuff on. And then foam in there, which I did a little different than I said initially, but you know, you test, you change things. And then foam in there, and then those are my connections. So now I need to build the backpack that holds the CO2 tank, the regulator, and I hook my wires up to the power supply. And it's finished. Let's figure this out. I need to put this on there, and this, which is my battery pack full of AA's. Alright, so this is what I'm going to build. Time to cut it out. Here we go, last piece. Now I just got to rivet it all together and throw straps on it. One strap, two strap, three strap, four straps. Just like one fish, two fish, red fish, blue fish. Yeah. Now, if you ever find yourself in the situation where you have a POWERFIST and you have a CO2 tank and you have a regulator and you have a battery pack, but you don't have any way to hold them, and you happen to have a propane torch, a bunch of rivets, a rivet popper, and some sheets of Kydex and nylon strapping and buckles laying around, you can have yourself a custom homemade backpack to carry the stuff in like an hour and a half. It's pretty simple. It's pretty fast. And really, that's, you know, that's a pretty specific situation, isn't it? Like a glove! You can't see it, but see if I turn right around, you should be able to see it. That is great. Yes! Backpack! It might as well be disconnectable, so I'm just going to put a plug on the wires, because the quick release on the airlines make the whole backpack disconnectable from the POWERFIST, so I might as well make it electrically disconnectable also. I hope you're as excited about this as I am, because all that's left to do is plug in my line there, plug this in here, and then flip the switch, and it's on. Look. Let me put it on. POWERFIST! Final product. It's all finished. Unfortunately, I can't show you it working because from testing and tuning, which didn't take very long because this thing basically just worked right out of the box, to mostly playing with it, I ran out of CO2. So I have to go get my tank filled again. If you want to watch it in action, make sure you subscribe, that way you can catch that video as soon as it comes out. And the commercial that I'm going to make for it, which should be a lot of fun. It's Batman approved. Yeah! Do you think somebody called PETA on me if I smashed, like, the head of something from a butcher? I mean, it's not getting used. Let me know in the comments what you want me to power fist. Or smash with the power fist, I mean. Yeah! It's really difficult to not want to hit everything to see what you can smash with it. It's really hard. That's probably why I'm out of CO2. Jesus Christ.